When in 1965, the Mariner 4 probe sent the first close-up photos of Mars, everyone was expecting water canals and alien creatures, but the images revealed a crater-filled desert. It was as if Mars was saying, "I have secrets, but I won't reveal them easily." This discovery showed that Mars has a thin atmosphere and a weak magnetic field, meaning solar winds stole its water and dried it out. But that wasn't the end. In 1971, Mariner 9 sent photos of gigantic valleys like Valles Marineris. These valleys were screaming that Mars was once full of water, with rivers flowing and perhaps life teeming in them. Now, fast forward to 1976, when the two Viking landers touched down on Mars's surface. They tested the soil, added nutrients, and observed gases that initially seemed like microbial breathing. Everyone got excited about this news, but it turned out the gases came from simple chemical reactions, not life. It was as if Mars was laughing and saying, "Don't judge too quickly." In 1997, Pathfinder arrived with the small rover Sojourner and examined volcanic rocks, showing that Mars had a fiery past. In 2004, the twins Spirit and Opportunity landed. Opportunity worked for 14 years, like an untiring champion. They found sedimentary layers indicating ancient lakes. In 2008, Phoenix discovered water ice beneath the soil in the North Pole, meaning Mars still has water, even if frozen. This discovery was like a spark. If there was water, why not life? In 2012, Curiosity went to Gale Crater and discovered mysterious methane, a gas that on Earth often comes from microbes like the smell of life. Curiosity also found organic materials, the building blocks of life, but not direct evidence. Moving ahead to 2018, InSight measured Mars's quakes and showed its core is still active, which helps understand its past climate. All these discoveries were like an incomplete puzzle. Water was there, necessary chemicals were there, but where's the sign of life? Now it's Perseverance's turn, the rover that landed in Jezero Crater in 2021, a place that was a large lake 3.5 billion years ago. This robot not only takes photos, but drills into rocks and collects samples. Its tools, like Pixel for seeing elements with X-rays, and Sherlock for finding minerals with lasers, are like a planetary laboratory. And now, the big moment. In July 2024, Perseverance reaches the Bright Angel area next to Neretva Vallis, a place where ancient water flowed. It finds a rock named Chayava Falls, about 1 meter long, with strange spots that scientists call leopard spots. Dark edges with bright centers, sizes ranging from tiny dots to millimeters. Inside these spots, they've found organic materials, carbon and things that are the basis of life, like the building bricks of existence. The edges are full of iron and phosphorus. The centers have sulfur and nickel, similar to a mineral called gragite, made of iron and sulfur, like a black chemical product. In addition, tiny grains of vivianite, a blue-green mineral made of iron, phosphorus, and water, are embedded in carbonates, like limestone. These combinations come from simple reactions where electrons move and materials change, like a natural battery that microbes on Earth use for energy. An article in Nature magazine, published on September 10, 2025, says this mud-like rock is rich in silica, aluminum, and iron, but low in magnesium, indicating ancient chemical weathering. The organic materials were identified with specific signals, and the spots might be from changes after the rock formed. What do scientists say? Joel Hurwitz from Stony Brook University. These combinations could have been an energy source for microbes. Katie Stack Morgan, project scientist. We've used all our tools, but for certainty, we need extraordinary evidence. David Grinspoon. This is the closest clue to ancient life, but there are many scientific traps. Sean Duffy, NASA director. This is the closest we've come to discovering life on Mars. But is it really life? Not so fast. These spots could be from chemical reactions without life, like in acidic or hot environments, but the evidence suggests a neutral and cool environment. Vivianite destroys in heat, and olivine, a green mineral sensitive to acid, remains intact. 3 other explanations were examined: high heat, unlikely because vivianite survives; acidic water, unlikely because olivine isn't destroyed; or simple catalysts, weak in cold. Ultimately, microbial life is the best option, but science proceeds with caution. I remember Carl Sagan saying, "Extraordinary claims require extraordinary evidence." So, it still can't be definitively confirmed. But there's an interesting theory called panspermia, which says meteorites can transport microbes. For example, the Martian meteorite ALH84001, found in 1996, had structures resembling fossils, though controversial. If life existed on Mars, perhaps the origins of some living beings are from these rocks, or in the past, these rocks brought life to Mars itself. Now, what's the plan? The Sapphire Canyon sample, one of 27 samples, is part of the sample return mission. NASA is collaborating with ESA, but the $11 billion cost has become problematic. As of September 2025, NASA is examining cheaper options like private landers. The timeline might extend to the 2030s, and the budget is threatening. It could even be canceled, but NASA remains committed. If successful, Earth's laboratories can provide certainty. Other missions like Europe's ExoMars, China's Tianwen, and NASA's Artemis are on the way. Mars, with every new discovery, becomes more like an unfinished book, full of clues from its mysterious past. Dried up rivers, mineral signs, and these suspicious spots all lead us to one fundamental question. Was there really life there? Science moves slowly but surely, and perhaps the answer to this question will change everything forever. What do you think? Has Mars revealed its big secret? Share your thoughts in the comments and hit the subscribe button for future adventures. Thank you for your attention.